Pag 163. By keeping the scale of the frames fixed, we can vary the focal length and therefore the flight altitude, with the possibility of analyzing also the elevations of the buildings facing the same road. The urbanista is accustomed to studying the territory through floor plans and would find it extremely useful to use a three-dimensional perspective view, obtained from low altitude with short focal length optics. Oblique shots should not be neglected, obviously renouncing to obtain scale prints from the same frames, for which the use of long focal lengths with vertical optical axis becomes indispensable. It is not risky to argue that, even in the case of aerial photogrammetric surveys, the client must collaborate in finalizing the survey, participating in reconnaissance flights. To remember finally, the possibility of requesting color shots, both in normal and infrared emulsion for particular applications. Caption: an example of a Siasic aerial photogrammetric shot, from which the reliefs are obtained in cartographic language. Together with the example shown on the left, this image gives an idea of the possibilities offered by stereophotogrammetry, to bring to the table of the urban planner any area of the territory destined to be transformed. Page 166. By moving, at constant intervals, the mobile brand in the direction of recovery and recording the movements in the plane orthogonal to it, we obtain the return of the curve of II velo, of which, on the left, we see an example taken from the relief of the Venus of Milo. Page 167. In the architectural survey, it is preferred to let the mobile brand travel the contours of the structural or decorative elements, obtaining, automatically, the passage from perspective to orthogonal projection. It should be noted that, in the graphic recording, voids, gray areas, or overlaps can occur in all those areas visible with the second type of projection, but not with the first or vice versa. To the right II result of a restitution exercise of the prospect of the ex-seminar of Matera, where, however, many gaps are due to the presence of trees. Page 168. The choice of information to be translated takes place via the mobile brand, therefore the return cannot be made by reading the model passively without understanding it. To derive the measurements from the pair of frames, we can follow the two ways previously identified. Measure, for each point, the two pairs of coordinates on the frames and, through them, obtain the spatial coordinates. Reconstruct the optical model and detect it directly or indirectly. The result is two categories of restitutors which we will call analytical and analog respectively. 7.1. Anal TLCL returners. We have already examined the relationships that link the spatial coordinates to the coordinates read on the frames. It remains to be seen if there are concrete possibilities to measure the latter with precision and speed. Page 169. The Wild Street 4 stereoscope transformed, with the addition of accessories, into a restitutor. The moving references of the frames are shown on slides, the distance of which can be varied with the precision of the hundredth of a millimeter. The operator varies the distance between the slides at constant intervals. Observes the mobile brand with magnifying eyepieces and moves the frame holder frame so as to always keep it adhering to the ground. A writing tip, fixed to the movable plane, can be lowered by the operator to the fixed plane and record the level curves. Drawing in the scale of the frame, it has a not very high precision, but certainly higher than that of the sketches that precede any architectural or urban planning project and that are independent of the environmental reality. Page 170. The simplest instrument we can use is the stereomicrometer. It consists of a bar of variable length, carrying two reference marks at the ends, the relative displacements of which can be measured with great precision. Observed with the stereoscope, The two reference brands merge into the mobile brand, which we can bring closer to our eyes by reducing the length of the bar. If the optical model is sufficiently flat compared to the shooting distance, the stereomicrometer proves to be a useful tool to measure, in the shooting direction, the differences of abscissa between two known limit values. By rigidly connecting it to the stereoscope, in order to respect the parallelism between the joints, respectively, the reference brands and the observation centers, and by fixing the frames with the right orientation to a mobile plane, equipped with a writing tip, we can also carry out a restitution with level curves, whose equidistance is a function of the parallax difference. Page 171. On the basis of the similarity of the trinagally outlined in the figure, the relationships between the coordinates of the mobile brand and those of the mobile reference marks on the frames are easily obtained. Page 172. To the left, the control scheme of the Wild C120 stereometric chamber, used to connect the autograph. To the right, the pair of stereometric frames, with the relief of the same provided by the manufacturer in support of the stereo camera. And this is a good opportunity to try your hand at the photogrammetrical restitution, analytically, using the formulas shown on the previous page. A first check of the error that we commit. We can do it by measuring the distance, 75 mm at the origin between the reference brands shown on the frames. Obviously, especially in the absence of an adequate magnification and a micrometer, the precision that we would obtain will not be exemplary, but will help us to overcome any possible prevention of stereophotogrammetric relief. Page 173. The relief, of a cartographic type, obtained will not be very precise, but may be useful for analyzing a bas relief or the deformation of the facade of a building. The instrument, indicated above, obtained with the composition of the stereomicrometer, the stereoscope and the mobile surface with a writing tip, can be suitably modified and perfected. The motion of the plane is broken down into two orthogonal rectilinear secondary movements, controlled by micrometric commands, according to the directions of the reference axes of the frames. The stereoscope is equipped with high magnification eyepieces, up to 30 and above, and the mobile brand taken sufficiently small. This type of device is called a stereocomparator and can make measurements to the nearest thousandth of a millimeter. It seems superfluous to point out that, with the use of ever more precise restitutive tools, there must correspond an equivalent increase in the quality of the recording equipment and, ultimately, in the pair of frames used. Page 174. Once the coordinates of the corresponding points on the frames have been obtained, we will never dream of reporting them in the table, to obtain, albeit with the aid of a calculator, the values of the spatial coordinates of each point of the model. There are automatic coordinate recorders that basically resemble drawing tables, equipped with their own reference system and capable of indicating, in real time, the exact position of a particular point of the drafting machine. By connecting one of these tables to the electronic computer, we can automatically store the coordinates, obviously with an order number. But on the computer, even if using an interpreter, we can order anything we want. For example, we can tell it to A. Memorize the coordinates of point A. B. Memorize the coordinates of point B. C. Perform the difference between the abscissas of A and B. D. Perform the difference between the ordinates of A and B. E. Square the result of point C. F. Square the result referred to in point D. G. Add the results referred to in points E and F. H. Extract the square root of the value obtained in G. If given the order, we bring the particular point of the drafting machine, which perhaps is better to call reader first in point A and then in B, or in two other points. The calculator will apply the Pythagorean theorem and provide us, in real time, the distance between the 2 points. Now let's try to perfect our photogrammetric tool, even with the imagination. In the moving plane, under the frames we place 2 coordinate recorders, making the reference system coincide with that of the frames, and identifying the reader with the reference brand. Caption: the graphics station of the world map system. On the table, measuring 122 x 91 centimeters, the reader with a magnifying glass is visible, with which it is possible to communicate to the bank DALI not only the coordinates of the points belonging to the drawing to be memorized, but also the symbols shown on a 25 x 25 centimeters table menu format. The non-graphic information is communicated to the computer via the keyboard and controlled, together with the graphics, on the video terminal. Page 176. The Tachimat Wild TG1 measures the distances from a reflector, positioned in the chosen points, reduces them horizontally or vertically, calculates the coordinates and records the data on magnetic tape cassettes. Its maximum range is 2 km, with a type error of 5 mm plus or minus 5 mm km. For reading data in real time. Has 2 8-digit LED indicators, controlled by a selector knob, to display the corners horizontal and vertical, the vertical angle and the oblique distance, horizontal angle and horizontal distance, height difference and reflector height, coordinates of the detected point. After some time, the data can be visualized by means of a writer, video terminal or be transformed into a graphic by means of a computer-aided drawing table. Page 177. The world map system is equipped with a PDP-11/70 microcomputer, right of the digital Pemonicore deck, normally used as a calculator, with a control console, the disk unit and a magnetic tape recorder, for the development of any program, even if not related to the database. Page 178. We communicate to the computer the 3 formulas, which link the spatial coordinates to the coordinates of the frames, and, for each position of the mobile brand, we will have the spatial coordinates that the same calculator stores as we have prepared. We can verify the results through the control points and have the necessary corrections made for all points of the model. Still with the help of the imagination, leaving the resolution of the technical problems to the specialists, we connect to the calculator, which we can now consider an integral part of our instrument. An automatic tracer, that is, a drawing board capable of receive orders from the calculator itself. Once we have chosen a reference plane, xy, xz, is, we ask the calculator to subsequently connect the points, according to our order, and we will obtain a graphic return. If the projection plane is not to our liking, in the case, for example, in which the elevation of the detected building is not parallel to the base of recovery, we can provide the computer with a new reference system, in our case, with a plane parallel to the prospect, and ask it to transform, before the graphic return, all the coordinates in the new system. We will therefore obtain the elevation in the desired scale directly on the automatic table. Even if we don't want to learn the language of the computer, but we have the collaboration of a good interpreter, all we have to do is express our desires. During registration, we can combine the points detected, in categories, to each of which we assign a code. At the time of the graphic recording, we will ask the calculator to communicate, at the drawing board, only the code of the category concerned and we will obtain a thematic map. For example, in the relief of the facade of a building, we can assign a code to the architectural elements, one to the static elements and another to the state of decay. Caption. Right. The universal system of analytical stereorestitution. Computer-aided. Wilder Vicolet AC1 with automatic table AVIATAB TA2. Conceived for the restitution of frames up to the maximum format 23 x 23 cm, obtained with any main distance and inclination. It allows to correct, by means of the calculator and a series of programs, errors due to lens distortion, film deformation, refraction and terrestrial curvature. The operator can guide the mobile brand, Luminous, by means of micrometric commands or with a freehand device, or lead it to any point with rapid movements, or, furthermore, make it follow any profile with adjustable speed. According to the chosen program, the system guides the operator by means of instructions communicated via video, exempts him from numerous tedious operations and signals errors. Page 180. For an exact positioning of the mobile brands, the observation optics are equipped with a zoom, which allows you to vary the magnification from 5.5x to 19x. The diameter of the visible field changes from 40 to 15 mm, and a selector allows you to adapt the luminous mobile brand, in shape, size and color, to the detected object. By means of manual or programmed selection, in addition to the normal stereoscopic vision, it allows the pseudo-stereoscopic and binocular ones of the right or left frame. All routine operations are simplified and accelerated by means of the calculator, of which the video terminal is located on the left, at a comfortable reading distance, and the alphanumeric keyboard near the freehand driving system. The video is not only used to communicate the instructions and part of the program, but also the accuracy of the measurements and orientation. The operator is therefore constantly informed about the quality of the work and can decide whether to repeat the measurements, choose other control points or eliminate some of them. A paper copy of the right frame can be placed in a special location, on the right, and allow anyone to follow the path of the mobile brand by means of a luminous point synchronized with it. The micrometric displacements of the mobile brand can be carried out with 3 transmission ratios, selected by means of a switch, while the rapid displacements can be obtained with a motor. For the automatic tracing of profiles, the speed can be varied continuously by means of a regulator, while for the positioning of the mobile brand on known points it is sufficient to provide the coordinates of these. On the plane left free in front of the operator, the electronic device for freehand driving is placed, also with 3 gear ratios. A marker allows viewing, cyclically or optionally, of the coordinates indicating the position of the references on the frames, of the mobile brand on the model, of the brand while describing a profile, of the corresponding point on the ground or of the writing tip on the drawing board. The AVILET is assisted by a Data General Nova 4x, 16 bits, 128 k-octets calculator, with the possibility of increasing the memory up to 256 k-octets. Other features of the calculator are the Integrated Memory Management Unit, the automatic device for entering the program and the combined unit of hard and interchangeable disks with a memory capacity of 12.51.2 m-octets. Page 181. For data storage, the AC1 can be connected to a magnetic tape drive, a punched tape reader, a tape puncher and a writer. All the peripherals, with the exception of the writer, are housed in a cabinet, together with the heat calculator and the electronic control unit. To the right of the operator, a second video terminal, connected to a camera, placed next to the writing tip of the AVIATAB TA2 table, allows the operator to precisely move the writing tip in reverse frame operations. A very handy command allows you to precisely move the writing tip and record its position. With the same command, Moreover, it is possible to lower and raise the writing tip. All this allows the operator to draw without getting up from the restitutor's command post. A servo control is available to the operator to adjust the height and inclination of the surface of the drawing table, also equipped with diascopic lighting, variable according to requirements. The useful surface is 120 x 120 cm, the possible inclination from 0 degrees to 75, the height variable from 80 to 110 crn. The maximum speed of the writing tip is 300 rnms. The tracer head support is equipped with 2 drawing points, to be chosen between pencil, pen and gravity point, for engraving, or it can be equipped with a magnifying glass and a luminous reference projector. A control keyboard is intended for recalling previously programmed functions. During the return phase, the operator can choose the symbol for representing a point, the type of line, point to point, line to line and continuous point, curved or straight, for the connection of 2 points, the speed of drawing, the type of writing tip. It can also draw parallel or perpendicular lines to others already drawn. Momentarily move the tip from the drawing area. The return takes place automatically, and complete a polygonal or any other drawn line. Page 182. During the graphic recording phase, if the overall relief is difficult to read, we can draw the points corresponding to the various codes with different colors or have them drawn on separate sheets. It is possible to assign a graphic symbol to each code. For example, in the relief of the existing greenery we can differentiate diseased plants and, with periodic surveys, have a clinical picture of the green area. We can use the calculator to update the reliefs. It is the case of the relief of road accidents. The calculator stores the entire city plan, complete with road signs, and the shapes of all vehicles in circulation. In the event of an accident, the emergency service patrol performs the recovery with a stereometric chamber, therefore minimum times, and communicates the accident area to the control unit. Pending the arrival of the frames, whose development can be immediate, for example with the Polaroid system, the computer is ordered to graph, in the desired scale, the area affected by the left. Once the frames have been inserted into the restitutor, the reference system is adjusted by means of control points common to the planimetry in the frames. For each damaged vehicle, 2 points common to the memorized shapes are detected from the frames and the computer is asked to take care, in the graphic recording, of the positioning of the latter according to the points detected. In an overall time, certainly less than that necessary for the removal of the vehicles, the accident survey, complete with all the details, will be stored and available, also, in pocket format. Particularly suitable is this type of restitutor in architectural and urban planning. The designer can graphic, in the necessary points, the planimetric and altimetric situation. Draw on it, by direct command, its own project intervention. Take advantage of the possible connection of the mobile brand with the writing tip to verify its validity. Memorize the construction elements and make them draw in the points desired. Memorize the final project, to obtain it, even after some time, on a video terminal or on paper. Caption. The world map system uses a level organization for data management. The first level divides the surface, object of the relief, by means of a regular mesh grid. The meeting of all the data relating to each shirt in separate tabs allows immediate access to those desired. In the second level, for each shirt, the data are divided into categories, up to 127, to each of which access is still immediate. In the third level each category can be represented with 128 characters, graphical and non-graphical. The texts and lists are stored in the non-graphic character card, For example, street names, owners, building types, age of buildings, etc. The graphic characters are divided into classes: straight lines, arcs of circles, interpolation curves, types of writing, symbols of points. Page 183. An additional table memorized for each calculator allows its representation in 64 different ways. So you can draw up to 128 x 64 equals 8832 symbols. Non-graphic characters are coordinated with graphic ones and automatically transcribed on the drawing. Page 184. The video terminal of the world map system for data management. 4. By means of it, it is possible to recall selected information among others previously stored. The numerical drawing is displayed on the graphic video, while the extracts of the texts, the lists and the work instructions, provided to the operator, appear on the alphanumeric screen, located on the left of the graphic one. Using a cursor, movable and visible on the screen, it is possible to freely enlarge or reduce, on the screen itself, a detail of the recalled graph. Page 185. An exemplary scheme of composition, of some equipment seen, for the acquisition, treatment and return of data. Data acquisition can take place through graphics station, for storing existing designs. Keyboard, while storing news or manually recorded data. Cassette player, in the case of automatic recording. The return can take place by means of automatic tracers, printer or video terminal. Page 186. The higher order differential straightening carried out by the aviaplane or one for the production of orthophotos, is based on a simple geometric principle. A linear element L, of the stereoscopic model, is projected on the horizontal plane in the linear element L. The restorer, of the aviolid type, is able to let us know the position or length of both the element L, belonging to the orthophoto, and the corresponding element L belonging to the frame to be printed in orthogonal projection. Note the initial length I and the final length L. The calculator must simply determine, for each element, the focal length with which to project the frame element that contains it. The aviaplane calculator, therefore, for each differential element, in which the frame has been decomposed, the projection focal length must vary according to the instructions received from the computer connected to the restitutor. Page 187. To date, it does not appear that, at least in Italy, someone has attempted to design a building or city with the direct help of a restitutor. Photogrammetric. The reasons, perhaps, will never be clarified, but, of course, if technological progress were to give us a helmet capable of displaying project ideas on a screen in real time, certainly many, because they would find exhaustive answers. In reality, these photogrammetric tools, similar to racehorses used to plow the soil, end up in the hands of those who use them to increase the quantity and not the quality of the product. The poor calculator, devoid of intelligence as he is, finds himself performing tasks that do not belong to him, with easily understandable results. 3 points are more than enough to identify an arc, even if this does not belong to a circumference. 2 points are enough to draw the edge of a building. It does not matter to check if and why it is not straight. If a prospect has a certain number of windows, more or less the same, the mobile brand does not cover them all. One is memorized and the computer is told to redesign it in the places where the others are located. Caption. Left, the baby of the aviolid family, the analytical restitutor wild BC1. On the right, below, the wild aviaplane or one for the production of orthophotos. Pages 188-189. The orthophoto can be obtained from any type of frame, but to achieve good quality, it is advisable to use long focal length lenses with a small angle of view and able to provide the requested information, despite the magnification. If you do not want to produce the orthophoto directly, the survey of the coordinates, obtained with a specially equipped restitutor, can be recorded on magnetic tape and used at a distance of time. Possibly integrated with surveys obtained by other restitutors. In the event that it is impossible to reconstruct the stereoscopic model, direct measurements of the photographed object and a particular program. SORA-OP, software for offline rectification in the aviaplane orthophoto, are used. Thanks to the same program, any numerical registration can also be used. Obtained free of charge during a graphic recording performed for other purposes, or from any elevation profile obtained, numerically, from the stereoscopic model. Page 190. On the 18th of May 193, the eruption of Monte Santina, USA, displaced 2.7 kilometers raised to the power of 3 of volcanic stones, devastated an area of over 500 kilometers raised to the power of 2 and determined one of the largest avalanches that history remembers. The U.S. Geological Survey of Menlo Park, California, in charge of checking volcanic activity, performed a series of orthophotos with the aviaplane 0R1. The one shown here, in original scale 1, 24.000, was obtained from a shot taken by NASA on the 19th of June, 1980, with an RC-10 camera equipped with UAGII lens and mounted on a U-2 aircraft, from an altitude of 19,500 meters. Page 191. On the right, 2 perspective views from the northwest of the volcano before and after the eruption, obtained by processing a return with the digital elevation model program. They show how the eruption has flown the last 400 meters of the summit and created a 750-meter deep crater. Page 192. An anaglyphic restitutor scheme. The displacements of the small screen, intended to accommodate the intersection point of the corresponding rays, can be recorded graphically in the XY, XZ and is planes thanks to the mobility of the XZ plane, in the Y direction and of the screen, on the same plane, along 2 orthogonal directions. To obtain the displacements, we can think of the servos, while for the graphic recording, respectively in the XY planes, is and XZ, to a writing point connected to the vertical guide of the screen, to the horizontal one and to the screen itself. Page 193. The relief thus obtained preserves all the shortcomings of the traditional relief, even though it is passed off as a precision relief. 7.2. Analog returners. A second way, which we have already identified, to automatically translate the information contained in the frames, from the photographic language to the graphic language, is based on the reconstruction in scale of the optical model and on its direct or indirect relief. A first type of restitutor, valid above all from an educational and economic point of view, uses the anaglyph procedure. The 2 projectors, previously examined, with their respective red and green filters, must be designed and constructed with particular care, so as not to introduce new distortions and alter the internal orientation determined by the camera. The relative and absolute orientation must be reconstructed with micrometric commands. Caption. An anaglyphic restitution scheme for aerial frames. The operator, using a micrometric drum, changes the height of the reference holder screen at regular intervals, and, for each height, moves the reference on the stereoscopic model. The writing tip automatically draws the contour lines. Page 194. The small screen, intended to collect the corresponding rays, will be equipped with a luminous reference, visible from both the right and left eyes despite the anaglyphic glasses. While the movements in the three fundamental directions must be obtained and recorded with particular precision. The system, bearing the luminous mobile brand, can be connected with a table equipped with a pantograph, for recording two of the three movements. It is also possible to obtain a numerical return by equipping the instrument with counters and devices for recording the X, Y, Z coordinates corresponding to the position of the mobile brand. The recording can be done on perforated tape, disc or magnetic tape to be then read by an electronic calculator, with all the advantages that derive from it. Another type of analog restitutor materializes, through metal rods, the two rays projecting the moving references of the frames and, for this reason, takes the name of mechanical projection restitutor. Conceptually it is the simplest, because it takes up the projection scheme used in the shot and reverses the procedure. In practice, each rod that displays the projecting beam is connected on one side to the twin and on the other to the mobile reference brand of the frame, while it is cardanically hinged in the projection center. When the distance between the projection centers corresponds to the base, reduced to the desired scale, the meeting point of the rods, corresponding to the mobile brand, can describe the optical model and, by registering the three-component motions, provide a graphic or numerical restitution or communicate with the computer. The resolution of the construction problems, as usual, I leave to the specialists, while we limit ourselves to analyze the functioning of one of these restitutors, the autograph Wild A40. Designed and built to avoid frequent calibration operations, this instrument, without sacrificing a high degree of precision, has all the requirements for introducing self-service in photogrammetry. Page 195. Planimetric scheme of the Wild A40 autograph. The rods, which materialize the optical axis, are hinged at points 0 and O, which constitute the projection centers. The main distances, F and F, can be varied by moving, along the rods, the guides indicated with P and P, which we can identify with the movable references of the frames, even if these, for construction reasons, they have been moved laterally in P and P, of a constant size. Even the auctions, for construction reasons, do not meet in the mobile brand, but have been spaced. The base is inserted by moving the end of a rod, by length bx, instead of distancing the projection centers. At least planimetrically, now, the restitutor works. The references on the frames, movable independently of each other, can be brought to the corresponding points and the mobile brand P draws the plan in the scale in which the base has been reduced bx. However, the scheme must be completed in order to allow the exact positioning of one room with respect to the other, by means of the bx, by and bz movements, the orientation of the frames in the I-astroport plane and the movements, also in height, of the references on the frames. Page 196. Left, the schematic of the A40 complete with the control elements. Right, the A40 elevation where it is possible to recognize 1. The main switch, 2. The switch for recording displacements according to the Y, or Z, axis. 3. The unregistered displacement meter, Y or Z. 4. The crank for the movement according to the Y, or Z, axis. 5. The rotating pedal for movements along the Z, or Y, axis. 6. The pedal that electromagnetically controls the lowering of the writing tip on the sheet. 7. The crank for movements along the x-axis. 8. The carriage release lever in the x direction. 9. Gioculars for the observation of the stereoscopic model. 10. The knobs for entering the main distances. 11. The rheostats to adjust the lighting of the frames. Page 197. Some technical features, detectable from the catalog, are not very enthusiastic. Restitution of shots taken only with the normal case. Main distance variable between 54 and 100 mm. Maximum plate format 92x 125 mm, with longer vertical side. Maximum image format 80x 80 mm. Maximum dimensions of the detectable optical model 350x 400x 300 mm. Fixed magnification of the 10x observation optics. On the operational level, however, with the stereometric chamber C120 it constitutes a combination whose performance is clearly differentiated from any restitutor, albeit analytical. Especially in the architectural survey, where often the return time of a pair of slabs is reduced to a few minutes. The time needed to center the frames and reconstruct the optical model takes on a greater weight. With the autograph A40 it takes into account also the introduction of correction factors. It is comfortably contained within 5 minutes. Page 198. The operations are easily listed. Insertion of the frames in their respective seats. Centering of the frame references with the corresponding ones of the plate holder frames. Introduction of the correct main distances, respectively on the right and on the left. Correction of convergence and lateral centering. Introduction of the base for each metric chamber. The correction factors are determined, once and for all, by means of special control plates that are part of the kit of the chamber itself. Equipped with a table, also with mechanical transmission, the A40 can work for decades even in places without assistance centers and air conditioning. Docile with all those who are seriously interested in the survey, it requires a training time of no more than a week. Which is necessary above all for the new operator to learn to move his hands and feet independently to guide the mobile brand on the three-dimensional optical model. Page 199. In fact, he has a crank, on the left, for movements along the x-axis. A crank, on the right, for movements along the y-axis, for graphic recording in the z-plane, or according to the z-axis, for recording in the xz plane. A rotating pedal, to the right for movements in the third non-adjustable direction. DL and electric pedal control, on the left, to make the tip of the table writing. It is a type of driving that can be easily learned if the focus is on the mobile brand, rather than on the controls, and which is undoubtedly simpler than the automotive one. Where hands and feet not only do not stand still on the same command, but they must choose the right one at the right time, often. In unfavorable psychological conditions the mechanical precision with which the A40 can measure the optical model is 1/100 of a millimeter and, of course, it remains only if the model is in scale 1. 1. Caption. On the left, the correction of errors encountered with control points. A convergence error transforms segment 1-3 into curve 1-3 and moves it away from section 2-2. B. A divergence error transforms the rectilinear segment 1-3 into the curvilinear segment 1-3 and brings it closer to the section 2-2. In the A40 this type of error can be corrected by means of the lateral centering button of the left frame, as regards straightening, zone II of the figure, and on the knob that regulates convergence. For approaching and moving away, zone L. Right, the AVIA-TAB-TE automatic table and the WILD EK data acquisition system. On the left, the orientation of the frame in the A40. The operator has 2 micrometric screws for movement, in height of the side, right and left of the frame and 1 base for movements in the horizontal direction, by means of which, with successive approximation, The reference marks of the frame must coincide with those of the fixed frame. Page 200. Also mechanically, it is able to straighten, during the graphic recording phase, 30 degrees or 60 degrees inclined shots. Using a knob, it is possible to instantly switch the connection of the right-hand crank with the Z or Y axis, for the registration of elevations or horizontal sections. Coupled with the Wild P32 metric camera, in normal case shooting, it can be used for surveys of urban environments and, with the specially adapted P32 or with the C40 atherometric chamber, for surveying small objects. For the use of the A40 in a database, the manufacturer Wildhybrid has provided the connection with the AVIATABTE assisted drawing board, the EK12 coordinate display, the EK22 data acquisition system, with which it is possible to access the world map system for data management. Caption. From top to bottom, with reference to the autograph A40. Observation optic scheme return room on the left. 1. Screws for correcting convergence. 2. Screws for centering the reference marks. Page 204. The Wild EK Data Acquisition System. From the left, the EK22 system, adaptable to all Wild restitutors, can simultaneously display 4 numerical values, freely program the recording sequence and transmit data, simultaneously. Up to 3 peripherals. The EKU system, provided as an accessory for the Wild AVIAMAP AMU restitutor. Just like the previous one, it allows to record coordinates of points up to 8 digits. The EK20 system represents the most economical equipment. Unlike the EK22, it alternately displays the measured values and can be connected to only one peripheral device. The EK12 coordinate display, which can be used when automatic registration is deemed superfluous, allows the simultaneous reading of the 3 coordinates indicating the position of the mobile brand. Right. II return analog Wild AVIAMAP AMU. Page 206. The Wild AVIAMAP AMU can be connected, for the graphic restitution, to the AVIATABTE automatic servo control table, whose useful surface allows the restitution of a whole model enlarged 6 times and in any case oriented. The maximum magnification is 10 times. For numerical restitution, it can be connected to the EK system for automatic recording, which according to the program, can be made for time or space intervals, with output on a writing device, card or tape puncher, magnetic tape recorder or directly to a mini calculator. For the orthophotographic return, to the AVIAPlan 1. The AMU, equipped with the PU device, allows the automatic exploration of the model, through parallel profiles, possibly according to a chosen azimuth. The model coordinates obtained are processed through the Sora OP program, for the calculation of the image coordinates needed to guide the AVIAPlan 1. Page 207. On the right, the Wild AVIAPlan wrap system, for the direct stereo restitution of a computer. It consists of a table. Automatic AVIATABTE, controlled by a Micronova MP100 data general computer. 16 bits, 64K octets with data general D100 video unit. The dimensions of the table are 100 x 120 centimeters, with the possibility of inclination from 0 degrees to 81 degrees and maximum speed of the writing tip, in the direction of the axis, of 125 mm s. Page 208. Intended for the preparation of the return project, these programs allow the storage of several hundred coordinates of control points, which can be recalled for the orientation of the stereoscopic model. The production and storage of symbols, up to 999, for the creation of an individual library. The symbols are drawn on a large scale and memorized through the aviatabte. To directly call up, using the control keyboard, 10 symbols chosen from those existing in the library, 10 types of lines chosen from those stored in the type of continuous display of the coordinates on the video. To the right, an extract from a symbol library. Page 210. Programs for the preparation of the model, which allow preparation of the return minutes, with automatic tracking of the reference grid and control points. 256 characters can be entered, transcribed on the minute with the position, size and inclination of your choice. The numerical determination of the parameters for absolute orientation. Up to 15 control points can be considered simultaneously, identified planimetrically and altimetrically, X, Y, Z, or only planimetrically, X, Y, or only altimetrically, Z. When there are more than 3 control points available, mathematical compensation is performed. Page 211. Computer-assisted return programs. Symbol. The representation of points or isolated surfaces can be obtained both with symbols assigned to the keyboard and with symbols of the library. Height annotation for the automatic transcription of the legends, of which it is possible to choose the size and inclination of the writing of the quota relative to a point, with the possibility of choosing the size of the digits, the position relative to the symbol and the inclination. Offset for moving the writing tip from one position and automatic return, with choice of the direction and length of the movement. Page 212. Line automatic connection of 2 points by means of a straight line, which can be drawn in 10 different ways, dashed, continue, etc. Curve automatic return of all curved lines. If you change from a curve to a straight line, simply press the line key in time to obtain a perfect fitting according to the tangent. Parallel automatic drawing of a line parallel to a polygonal or a curve, with the possibility of choosing the distance between the two lines and the section of the parallel line. Complete automatic closure of polygonal or curved lines, with return to the starting point, for example, in the representation of buildings. Page 213. Feet automatic drawing of perpendicular lines, for example, for the completion of building plans. Shade for hatching areas of the design delimited by polygonal or curvilinear lines, with the possibility of choosing the inclination and equidistance between the sections. On the right, the PFKB1 control keyboard and the CRT video terminal designed to make the dialogue between the operator and the computer as simple as possible.